Hello friends, welcome to the course Multivariate Procedures with R. You can recall that in the last lecture we initiated a discussion that how different types of arithmetic operations are taken care in the R software, how R works on them. And we had taken the examples of very simple calculation just like a calculator, addition, subtraction, division, multiplication, power operations. Now the strength of R software is the way it handles the data vector. What is a data vector? You can recall that if you want to combine the different values in the R software, then you have to use the command C, lowercase c. And the data vector helps the R software in understanding or informing that R has to do the operation over the each and every value inside the data vector. So now the next question comes, how R works with the data vectors? That is, we have to understand. This understanding is going to help us when we are trying to write our own program. Means our programs are our need and they are dependent on us, that and we have to take a call that how they have to be computed. It's not R, but we have to follow the rules which R is going to understand, because they have been built in inside the software. So that is why in this lecture it is important for us to understand how R software works with the data vectors. And based on that, you have to do your programming to get done what you want from R. So let us try to take here several examples and try to understand that how R works. So let us begin our lecture. So now in this lecture we are going to take up two topics. One is data vectors and another is built-in function, but let me try to first address the data vectors topic. Now you understand what is the data vector. So there are here 4 values, if you try to see 2, 3, 5, 7, and you have used here a command here C. So this is actually here a data vector. One point where you have to be careful in understanding is that vector is a very general word and this is used in different subjects in different ways. There is a vector in physics, there is a vector calculus, there is a vector in mathematics, etc. And there is a vector in matrix also. But this is actually data vector. The only difference between data vector and others is that data vector is simply trying to combine different values in the same order in which they are written. For example, if I say C 2, 3, 5, 7, then R will try to operate first on the first position number, then on the second position number, then on the third position, and then finally on the fourth position. And this is different than if I write 2, 5, 3, 7. So they are not the same. That is what you have to keep in mind. So whenever I use the word data vector, that means there are some numerical values which are combined with the C operator. So now first let me try to take how mathematical operations are done when one component is a data vector and another component is a scalar. Well, just for the sake of understanding, I am going to take here only very simple example where there will be only 2 values in general, so that I can explain you that how R is going to work. So, and this I am going to do with the help of several examples. So, if you try to see here, I am taking here an example C 2, 3, 5, 7 and a scalar 10 is going to be added. Now, the outcome here is like this 12, 13, 15, 17. Next question comes, what R is doing such that this outcome is coming? So, actually this is what is happening, that if I try to write down here C 2, 3, 5, 7 plus here 10. So, this is a scalar. So, this part, this is operated over each of this number. So, basically this happens like this 2 plus 10, 3 plus 10, 5 plus 10, 7 plus 10. That means in a nutshell what I am trying to say, that this operator is going to be operated over each and every member in the data vector, and that will be the outcome. Here in this case, in this first case of explaining you the addition, please try to understand the basic logic. and the same concept will be replicated with other operation like a subtraction, multiplication, division, etc. So, here in the first part, in the first case, I will try to give you details in more, but after that I will be faster. So, and then you can see here, this is here the outcome in the R console, right. So, now the next question comes here, if I have two components and which are data vectors, and another part where you have to be cautious is that size of the data vector. Size of the data vector means the number of elements in the data vector. So, first I am trying to take here a case where the number of elements in each of the two data vectors which are going to be added is the same. So, in each of these data vector there are 4 elements, 4 numbers, right. So, now how this operates. So, let me try to explain you, please try to understand it, I will go pretty slow. The addition in data vectors is done element wise or say position wise. First element of the first data vector that is added to the first element of the second data vector like this. Then the second number or the number at the second position in the first data vector, which is here 3, is added to the number at the second position in the data vector 2. So, this and this 3 and minus 3 will be added. And similarly, I am trying to use here a different color pen so that you can understand it. The number at the third position in the first data vector is added to the number at the third position in the second data vector. So, this 5 and minus 5 will be added. And finally, the last or the fourth element in the first data vector is added to the fourth element in the second data vector. So, if you try to see this operation, this is going like this, 2 plus minus 2, 3 like this, plus minus 3, 5 plus minus 5 and 7 plus 8, right. And this plus operator, this is being replicated from here, right. So, you can see here this outcome comes out to be here 0, 0, 0 and 15. It is not difficult to understand for you. So, but and if I try to give you a quick revision, it is something like this, C 2, 3, 5, 7, and if I try to write down here minus another data vector minus 2, minus 3, minus 5 and 8. So, we try to add it here. So, this and this get added, this and this get added, these two numbers get added, these two numbers get added, and we obtain the outcome here. So, this is how the addition is working. Now, when I will be talking about the subtraction, division, multiplication, etc., they will also be following the same rule. Only this plus operator will be replaced by the respective operator. Now, in this case, we have taken the two data vectors of the same size. Now, I am trying to take here the data vectors of two different size. You can see here, this is my here data vector 1, which has 4 elements, and I have here second data vector which has here 2 elements. And if you try to execute it, the outcome will come out to be like this. So, now this creates the confusion in the beginning that what R is doing so that this outcome is coming. So, let me try to explain you. What happens that if I try to write down here 4 numbers here 2, 3, 5 and 7. This is my data vector 1 and the second data vector here is C 8 and 9. Now, after this, when the operation starts, then first this 2 and 8 they get added and answer comes out to be here 10. Then similarly, the numbers at the second position in the two data vectors, they get added and we get here the value here 12. Now, after this, when R tries to move forward, then it does not find anything here that what is to be added. And in such a situation, what R does, it will try to replicate the same numbers again. So this 8 and 9 will be added here automatically, and then 5 plus 8 13 and 7 plus 9 16. This will be the outcome which we are getting here. So this operation is happening when we have the these two data vectors of different lengths, but there is a prime condition. If you try to look at the number of the elements in the two data vectors, they are the exact multiples. Exact multiples means 2 is here, so and here it is 4, so 2 2s are 4. So first of all, if I try to explain you here, this C89, this comes here and it tries to operate over 2 and 3, then C89 comes here and it tries to operate over 5 and 7. So this is how the R works with the data vectors. Now let me try to give you an example that where the number of elements in the two data vectors are not exactly in the format of exact multiple. For example, you can see here this first data vector, this has 4 elements, and the second data vector has 3 elements. Now in this case, the outcome comes out to be here like this 10, 12, 15, 7, 15, 15, but it always gives you a warning message that the longer object length is not a multiple of the shorter object length in this one, and that is correct. The shorter object length has value 3 and the longer object length has the value 4. There are 4 elements and 3 elements, and 4 is not a multiple of 3. This is how we are going to interpret different types of messages which R is trying to give us, right? But now the next question comes, what is really happening and how this object is fulfilled and how this outcome can be justified, what R is doing. So now let me try to take a similar approach, and if I try to write down here the 4 values 2, 3, 5 and 7 here, and if I want to add here another data vector, it will be here 8, 9 and 10, right. Now as R starts working on it, at the first place what it tries to do, that it will try to add the numbers which are at the first position in both the data vectors. So 8 plus 2 becomes here 10. Then R moves forward and it tries to add the numbers at the second position, which is here 9 plus 3, which is here 12. Then it moves further and it finds the numbers at the third position in the data vector 1 and 2, and it tries to add here 5 plus 10, which is here 15. Now after that, when it moves further, there is no number here. Now once again R get confused, and so what it tries to do, it tries to repeat the same number again 8, 9 and 10. So this 7 and 8 gets added here and it comes out to be here 15, but now there is no number here in the first data vector where 9 and 10 can be added, so this is not executed. And that is how this outcome 10, 12, 15, 15 is obtained here, right. So you can see this is a very peculiar way of doing calculation inside the R software, but I promise you this makes our computation and calculation very simpler when we try to write down the program. Now in case if I try to repeat it for this subtraction, same concept. When I am trying to write down here one data vector subtracted by a scalar, then this minus 2 is going to operate over each of this number, and this outcome is obtained 0, 1, 3, 5, which is the outcome of this execution 2 minus 2, 3 minus 2, 5 minus 2 and 7 minus 2. Similarly, if you try to take here two data vectors of the same length, then as we have seen in the case of addition that the element wise addition is happening, so here the element wise subtraction is happening. This number 2 and this number 2, which are the position number 1 and 1, they get subtracted here like this. Then the second element in the two data vectors 3 and minus 3, they get subtracted here. Similarly, the numbers at the third position in the first two data vectors, data vector 1 and 2, 5 and 4, they get subtracted here like this, and finally 7 and 1, they get subtracted, which are at the fourth position in the two data vectors. So, if you try to see, this is the same operation which was happening in the addition also, but the only thing is this, now we have a subtraction. So, this subtraction operator is being executed. Now, similar to the case what we have done in the case of addition, let me try to take here the next example where the first data vector has 4 elements and second data vector has 2 elements, such that the number of elements in the shorter data vector, they are exact multiples of the numbers in the longer data vector. Right. So, the same operation comes here, that this C12 gets operated first over this C23, and then after that once again it comes and it gets operated over 5 and 7. So, this 2 minus 1, 3 minus 2, 5 minus 1 and 7 minus 2, that gets operated and we get here this number. Right, and you can see here, this is here the outcome of the same operation, right. And now, in case if you try to take here two data vectors in which first data vector has suppose 4 elements and the second data vector has 3 elements. So, definitely it is not the exact multiple. So, what will happen? The same thing what we did earlier, C2, 3, 5, 7 with C1, 2 and 3, and now it will be subtraction. So, this and this will be operated, 2 minus 1 as 1, 3 minus 2 here as a 1, 5 minus 3 here as a 2, but now there is no element over here in the last position in the second data vector. So, this 1, 2, 3 will be repeated. So, this will become here 7 minus 1, which is here 6, and this data outcome which you can see here, that is obtained, but a warning message is also given that you have to be careful what you are trying to see. Well, in R there are two types of messages which come, one is warning messages and other is error. So, it has the same meaning whatever is the literal meaning of warning and error. For example, we always warn our student, if you do not study well, then you are going to be failed, but we do not do anything after this. But during the exam, when a student is getting below the threshold mark, then the students get failed. So, that is an error. After that, we cannot do anything. But warning is something like a warning which has to be corrected. So, R is trying to give you a warning to indicate you that there is something which is not correct, but you have to see whether it was done intentionally or is it a mistake. Now, as a programmer, I have to see whether this is what we want or I have made an error, and then we have to take a proper decision and then the things will be done. Right. So, now before I try to take the multiplication example, let me try to show you these things on the R console also, so that you get confident. So, if I try to take here, suppose here some element here, some data vector 2, 3, 4 and 5, and if I try to add it here with here another say here some number, suppose here 10. So, you can see here this is means 2, 3, 4, 5, every number has been added with 10 and the outcome here is 10, 12, 13, 14, 15. Similarly, in case if I try to take here some data vector, suppose if I try to see here data vector 1 and 2. So, now this is exact multiple. So, the answer will come out to be 2 plus 1, 3 plus 2, 4 plus 1, 5 plus 2, and if I try to take here another data set of say size 4 with elements say 1, 2, 10 and 20, then you can see that the respective positions are going to be added by the respective numbers. And if I try to make it say in such a way such that the length of the shorter data vector is not the exact multiple of the longer data vector, then it is giving us a message that okay, you are trying to do something, please try to be careful. If there is a mistake, please correct it, otherwise you leave it. Now, similarly, I can take the example of here say subtraction. Suppose if I take here to C 2, 3, 4, 5 and if I try to subtract here say 5, So you can see here this 5 is going to be subtracted from each and every element in this data vector, and this will become a 2, 3, 4, 5, and every element is being subtracted by 5. Now similarly, if I try to take here another data vector here, say C1, 2, so now the respective positions are going to be subtracted and it is going to be repeated. So you can see here 2 and 3 subtracted by 1 and 2, then once again 4 and 5 being subtracted by 1 and 2. And similarly, if I try to take here the data vector of size 4, then you can see here, this is here, the respective positions are subtracted and we have this type of answer. And if I try to make the number of elements in second data vectors to be not exact multiple of the first data vector length, then it will give me a warning message, and the outcome will be the be here like this, right. So this is how you can see that whatever I explained you, the exact same thing is going to work inside the R console also, right. So let me try to come back to our slides and let me try to give you some idea about other operations. So now the same thing will happen with the multiplications and division also. So you can see here this C2357, when it is multiplied by scalar 3, then this 3 is being multiplied over each and every number, 2 into 3, 3 into 3, 5 into 3, 7 into 3. Right, and we get here this number, right. And similarly, if you try to take the two data vectors of the same length, then 2 and 2 minus 2 are going to be multiplied, 3 and minus 3 are going to be multiplied, 5 and minus 5 they are going to be multiplied, and 7 and 8 are going to be multiplied. So again, once again, this multiplication is happening with respect to the position number, first position with first position, second position with second position, and so on. And these are here the screenshots, so that you can be confident that if you try to execute them in the R console, then you can do it easily, right. And similarly, as we have taken the example in addition and subtraction, if I try to take two data vectors in which one's length is 4, there are 4 elements, and in the second data vector there are only 2 elements. So the length of the smaller data vector is an exact multiple of the length of the second data vector. And then again the same thing happen if I try to explain you 2, 3, 5, 7, and see here C8 and 9. So now there is multiplication. So the numbers at the first position they get multiplied, numbers at the second position they get multiplied. Now there are no more numbers, so this 8 and 9 are repeated, and the respective multiplications at the respective position elements takes place. And if you try to take here one more example where the number of elements are not the exact multiple, then in that case, as usual, this 8, 9 and 10, they are going to be operated on the first 3 elements 2, 3, 5, and after that this 8 will be operated over 7, but now there are no elements where this 9 and 10 can be operated. So you will get here a warning message, and the outcome here will be like this, right. And these are the screenshot of the same operations. So you can see here that it is not so difficult to understand, provided if you have understood the addition and subtraction. Now we try to consider the division, which is also being done exactly on the same logic as addition, subtraction or multiplication. So if I try to take here a data vector here C2468, and if I try to divide it by scalar say 2, then this 2 is going to divide each and every element in the data vector, and we get here this outcome 1, 2, 3, 4. And similarly, if I take here one data vectors of size 4 and another data vector of size 2, then this division is going to be happening over the first 2 elements, then once again over the remaining 2 elements. Then the logic is the same which you have used in the addition, subtraction and multiplication, and you get here this answer. So this is the operation which is happening here. Now similarly, if you try to take here an example where the number of elements in the first data vector are 4 and the number, and in the second data vector it is 3. So this is not the exact multiple. So first data vector is having 4 and the second data vector is having 3 elements which are not the exact multiple. So you will get here a warning message, as happened in the earlier cases also, and yeah, this is going to be the outcome. And this is here the screenshot of the same operation which I have shown you here, right. So you can be assured that the same operation is going to happen. Now we come to our last operator, which is the power operator. This is again the same what was happening with the other three simple. Suppose if I try to take here one data vector having 4 elements, and if I want to take the power operator 2, that means each of this number is going to be squared like this, and this is here the outcome. And instead of a hat, if you try to use here 2 stars also, that will also give you the same outcome. So you can see here, just like other operation, this power operator is going to work on each and every element in the data vector, right? And similarly, if you try to take here 2 data vectors, one is of say length 4 and another is of length 2, then this operation will happen here. This 2 and 3 will come here, and once again it will repeat as 2 and 3 here, and this is here the outcome, right? So this operation is being operated here. And similarly, if you try to take number of elements in the second data vector which is not the exact multiple of the elements in the first data vector, then this power operator will come here and it will make a 2, 3, 4. This will operate, and then it will start repeating again 2, 3, 4. But after 2, it does not find any elements, so it will give you here a warning message, and the outcome will be displayed here. So this is the screenshot of the same operation which is being done here. Right. So now let me try to show you these operations on the R software also. So you can see here, if I try to take here the multiplication, if I try to take here say any, we say this data vector here 2, 3, 4, 5, and if I say here divided multiply by 2, this is the number, and if I try to replace it by the scalar by data vector 2 and 3, so this is the element wise multiplication, and it is here like this. And then in case if you try to take care the same number of elements in both the data vectors, once again they will be multiplied by the respective elements. And if you try to reduce here the length, which is not the exact multiple, then you will get the error. And you can see here that the same operations I can do with the division also. If you see here, if I try to take the first data vector and second as say here 2, then the 2 is going to divide each and every element in this one. And if I try to take here the second data vector, which is the exact multiple of the length of the first data vector, then the element wise division will happen here like this. And if I try to take here the data vectors of the equal length, then it will be here like this. And if I try to remove here one element so that the lengths are not exact multiple in the 2 data vectors, then you will get here then warning message also, right? And similarly, if you try to take here the power operator, so you can see here, if I take the first data vector and second as a scalar, this is going to operate it over the each of this number. And you can, and if I try to take here the second number as data vector of the multiple length, then it is going to be here like this. And if I try to take here say here the 2 data vectors of the same length, the power operator is going to be like this. And if I try to reduce the length in the second data vector, which is not exact multiple, then it is giving us the warning message, and the answer is here. Right. So you can see here, it is not a very difficult thing, but the main thing here is to understand it, what are we going to do. So after this small introduction to the calculation, let me try to give you here one more idea, which is a very strong feature in the R software. We have here some functions which are built-in functions. Built-in function means that they have been created by some authors and they are hidden inside the software. And if you want to do something for which the built-in function is available, then you need not to do the whole programming, but you can directly use it. For example, if I want to find out the arithmetic mean, so arithmetic mean of x1, x2, xn, these numbers is defined as summation of all the number divided by the number of elements. But now you have two options if you want to compute this arithmetic mean, that you write the whole bunch of program and then you try to use it, or you simply call them by mean of here x, where x is containing all the data points x1, x2, xn. Right. So, each of this built-in function, they have been designed to do some specific task. And that is the advantage, that when we try to do the programming and suppose we want to find out the arithmetic mean, I can simply call the function mean of x and it will give me the data vector. And if I want to find out the square of mean, then I simply have to write down here mean of x and hat 2. That's all. So, this built-in function also works with the usual mathematical principles, and they work with the data vector as well as the scalar. So, let me try to give you some examples so that you can understand it. For example, if you want to find out the minimum of some number, so for that the command here is min. And if I write down here min and inside the parenthesis I try to write down the value. Here I am trying to do something special which I will try to explain to you. I am trying to write down the same command here, but once I am using the operator lowercase c, and here I am not, no c operator is used here, and I want to explain you something. So, please have a patience and try to understand what I am trying to say and don't get confused. So, if you try to just operate this function here min and write down the numbers inside the parenthesis, it will give you here the minimum value which is minus 7.8. But here I have not used the C operator, that you can see, but now I try to use here the C operator, and yeah, I try to give you here this the same numbers, answer is coming out to be the same, and this is here the outcome. So, now it raises a question here, what should I do? Should I use the mean this C operator or not? Well, I would like to inform you that this is happening only with some of the functions, and some functions will take the values only when they are in the form of C command, data vector. For example, I can give you the example here, mean. You have to give the values inside the parenthesis using the C operator, and if you try to give the value of here C without giving any C operator but only the values, then it will give you the mean of only the first observation, that is itself only the first observation. Now, here will be a bigger trouble. This answer is correct and this answer is wrong. But when you are trying to write down this function inside a program, then whatever is the outcome of the wrong answer, this will be carried forward and your entire program will become wrong. It will give you a wrong value. So, on the other hand, if you try to use here the C operator, then either this is mean or say minimum, both are giving you the correct value. So, my advice to all my students is that please always use the C operator without any exception. No exception, just use C operator to combine your data values, right. The same thing happened with the maximum also, but anyway, this is difficult to decide that which of the function is doing what. There can be different reasons, but I am not going into those reasons why this is happening, but I wanted to inform all my participants and students that they have to be watchful and careful when they are trying to write down their program. Similar to minimum and maximum, we have many other functions, like as if you want to find out the absolute value, there is a function ABS. If you want to find out the square root, then the function here is SQRT. If you want to make the operation like rounding up and down, round, floor, ceiling, etc. there. If you want to find out the sum and product of the numbers inside the data vector, you can use here the command sum and product. Different types of logarithmic function, they are defined by here log, log 10, log 2, and exponential function, trigonometric function, sine, cos 10, and then cosec, sec, cot is by a sine, a cos and a tan respectively. Hyperbolic functions like as sin s, cos s, tan s, etc. They all are available, and there is a long list. I am just giving you an example here that what is available. But my one advice to you all, suppose if you want to find out here the log, in sometime we simply write here log, then you have to see whether this log is giving you the value which is base 10 or this is here log, natural log e. So, for that I always prefer that first look into the help menu and try to see what the log function is doing, and then you try to do it. So, let me try to give you here some example that how it works. So, for example, if I write down here absolute of minus 4, then you can see here it is coming out to be 4, and it is scalar, there is only one value. So, there is absolutely no issue. But when you are trying to take here the data vector over the absolute value, so now this absolute function is operated over each of this value, and then it is here the outcome. The absolute value of -1 and -2, they are 1 and 2, and so on. So, and this outcome is obtained here. Now, similarly, if you want to find out the square root function, so square root of a scalar, say 4, it is 2 here. So, without writing any program, you can simply direct write sqrt. And if you use this sqrt function over a data vector, so this square root function is operated over each of this element, and you get here the correct answer. And this is here the screenshot of the same operation. So, you can see here that these functions are working over scalar and data vector. Similarly, if you want to use here sum, so if you try to use here sum over the data vector 2, 3, 5, 7, it is trying to add all these values. Similarly, if you want to multiply all the values inside a data vector, then the PROD function, when used with the C operator, is trying to multiply all the values together. And simply we know that the round off of 1.23 is 1, and round off 1.83 is because it's 2, because it is more than 1.5. So, these are here the different screenshot by which you can see here. And now I would just try to give you a quick illustration inside the R software. You can feel more confident. So, suppose if I say here absolute value of here -2, so you can see here this is coming out to be 2. And if I try to write down here a data vector C of here -2, -3 and 4 and here 5. So, you can see here this will come out to be 2, 3, 4 and 5, right. And similarly, if I want to find out the square root of here 9, this is here 3. And if I want to square root of a data vector, say here 4, 9, say 16, 25 and so on. So, it will be here like this 2, 3, 4, 5. So, you can see here that these functions are going to work over the scalar value and the data vector both. Right. Okay. So, now we come to an end to this lecture, and you can see here I tried my best to give you a fair idea, a quick idea that how R works with the scalar and data vectors over different types of operations. Concept is the same. So, if you try to understand the first example where I have illustrated the addition with scalars and different types of data vector, the same concept is being operated over other operations like as multiplication, division, power operator, etc. And another big advantage which I explained you here is the use of built-in function. Actually, these are the couple of features because of which R became a very popular software, that instead of doing or writing this long program for finding out sum of squares, product, etc., you can just write them in a single line. For example, if I want to write a function for sum of xi square, means square the numbers and then add it, I can simply write as sum inside the parenthesis x hat 2, that is all. Whereas, if you want to write down the whole program, that will be a longer program by using the basic concept like sum equal to 0, num equal to 0, which you possibly used to do in your childhood. So, these are the very peculiar features of R software because of which R became popular. So, my request to you all will be, you please try to take up some example and try to practice it. I know you already know, but it is always a better option to prepare yourself and brush up your knowledge before going into the travel. So, we will start our journey for the statistical tool very soon. Till that, you try to brush up your knowledge and get prepared for the journey, and I will see you in the next lecture with more concept on this computation. Till then, goodbye.